So sine of 270, you really can't draw a triangle. But you can still find the sine of 270. You need to know what 270 looks like in standard position. It points down. There's a different color here. So that's your terminal side. Then you need to find a point on that terminal side. I think the easiest one to work with is 0, -1, but any point will do. Since you want to find sine, and since sine has r in it, you need to find r. But with this simple selection, r is going to be equal to 1. R is the distance from the origin to the point. You can find it with Pythagorean theorem. But as you'll see, you'll just get 1. Then you need to know what sine is in terms of x, y, and r. It's y divided by r. Your y comes from the y coordinate, in this case -1, and the r is +1. I just recommend that you use these points that I use. I think they're the simplest. And when you use the points that I have suggested, then r will always be 1. So y is -1, r is +1, therefore the sine of 270 is -1. Okay. Any questions on that process? Yes?
Do you recommend just like memorizing for each like sine, y over r, cosine?
I do. Yes. I recommend memorizing the trig definitions in terms of x, y, and r. I think that will make you more fluent. Okay, Alec, can you guide me through how to find the cosine of 90 degrees?
Yeah, alright, so the terminal side is going to be based on the x-axis.
Did you say x? I'm going to say y. Okay. So 90 degrees is here.
So it's going to be 0, 1.
Good. The point of interest is 0, 1.
Cosine is x over r.
Cosine is x over r.
Which is going to make it 0 over 1.
Good. The x-coordinate is 0. R, with the point selection that I have suggested, is always 1, but it wouldn't matter anyway. 0 over any number other than 0 is 0. Good. Any questions on finding cosine of 90? Yes?
No, I have one for the first one.
Okay.
Is it 1 or -1?
It is -1.
Okay, I only saw the 1 side.
Oh, that's the r. Another thing, r is always positive. Okay. Good. Scott, tan of 0. How does one find that?
Drop stable position.
Mm-hmm.
It stays on the positive x axis.
Good. Good.
And the
Good. 1, 0 works. Yep, because it's y over x. Mm-hmm. Good. Oops, sorry, this should be 0. Good. The tangent of 0 degrees is 0. And Julie, how can I find cotangent of 90 degrees with this method?
X over y.
So yes, cotangent by definition is x over y. Good. So you need the x and the y. How can you find that?
X is 1, y is 0.
So 90 degrees is here, right? You need to find the coordinates of a point on that terminal side, on that ray. So I would suggest 0, 1. Okay? Then you just do the x coordinate divided by the y coordinate. Because cotan is x over y. So 0 over 1, which is just 0. Okay. Any questions there? Nice. Alexandra, guide me through finding secant of 180 degrees, please.
So the secant draw a line straight across,
Yep. It's a straight angle.
and secant
Secant
is r over x.
is r over x. Very good.
So the point can be -1, 0.
The point can absolutely be negative 1, 0, yes.
So then you do r is 1 and x is -1, so the point over -1 equals -1.
Excellent. Okay. We good? And max cosecant 360. Guide me through that one, please.
The terminal side is just on the x-axis.
Which direction? Yep. Terminal side, which is what matters here, is pointing to the right. Okay. Good. Continue.
And it's r over y.
Good. By definition, cosecant is hypotenuse over opposite, but it might help you to know it as r over y. Good. Keep going.
So that's 1 over 0.
Yep, r is going to be 1 always with the points that I suggested. And the y-coordinate on the x-axis is 0. So it's 1 over 0, and max, that is undefined. Cannot sit on 0. Or as Jackie said, if it's under, then it's undefined. Okay. Any questions on finding trig function values for what are called the quadrantal angles?
So the cosecant is
Yes, cotan 90. Cotan is x over y. At 90 degrees, the x-coordinate is 0. That's all that really matters. Who cares what the y is? Because 0 divided by anything is going to be 0. Okay. Any other questions? Okay. It says, suppose that theta is in standard position. We know what that means. Vertex at the origin and initial side on the positive x-axis. Great. Done. We're also told that the given point is on the terminal side of theta. Okay? So 3, 4 is on the terminal side. No problem. I plot 3, 4. Easy. Check. That's on the terminal side. So there's a ray that goes through that point. And since it's in standard position, then the angle goes from the initial side on the positive x-axis to the terminal side, wherever it is. So that's theta. We want to find sine. No problem. I know that sine is opposite over hypotenuse. In other words, y over r. I have my y-coordinate. It's 4. I have half the answer. Now I just need r. R is the hypotenuse. It's the radius. It's also the distance from the origin to the point. Okay, that's r. This is y. This is x. So we are still working with right triangles. You can use Pythagorean theorem because it's a right triangle to find r. But this is a very simple one. Hopefully you can see that this is a 3, 4, 5 right triangle. But just to prove that to you, Pythagorean theorem, hypotenuse squared equals side squared plus side squared. And you can write this as r equals the square root of x squared plus y squared. And for your information, this is always how you can find r. with this formula. It's just the Pythagorean theorem re-expressed. Okay, so your x is your x-coordinate. It's 3. Your y is your y-coordinate. It's 4. I recommend subbing in with parentheses. Remember, r is always positive, so if you get a negative or a negative underneath the square root, something's not right. Okay, so this is the square root of 9 and 16. And 9 and 16 is 25. So that's just the proof that the hypotenuse is going to be 5. Then you just divide by that, and it's that easy. So the sine of this angle is 4 over 5. Okay, any questions on that? Yes?
So you're given x and y with the coordinates, but
Yes.
You always find r with the Pythagorean theorem?
Yes. And for things like tangent and cotangent, you actually don't even need it.
Okay.
Yep. Any other questions on what I demonstrated?
Why don't you use the
Tangent and cotangent only use x and y. They don't use r, which is the hypotenuse. Okay. Now, let's ask somebody at random. Alec. Jake. You want to try number 3? Yep. Yeah, so what's your first step? Yeah, 18 comma 24. It doesn't have to be perfect. And it's actually not even necessary. It's just, it might help you understand the situation. Exactly.
Draw a line down.
Yep. And how long is this side?
That side would be 24.
24. And this side?
That would be
18. And then since we are finding cosine, we need to find the hypotenuse. So how could you find that?
18 squared. Plus 24 squared
Yep.
equals that squared.
Yep. Good. Go ahead, use your calculator. Good. Good. Add those two numbers. I'm going to go with 900. Good. So we're almost done. Tell me about cosine. What is its definition? Excellent. Very good. Mm-hmm. Mm-hmm. Very good. Okay. So notice here we're just finding r, Pythagorean theorem, and then you just plug it into the definition. There you go. Trig functions, they are nothing to be intimidated by. They're just names. Okay, you just need to know what their definition is. That's all. Any questions on 3? Yes?
Not necessarily on 3, but on these problems in general, are we allowed to use calculators for this? Just to find the, I mean, you can multiply.
I'm not going to ask you to find numbers that are as large as these.
Right, because I did the next one, it's just hard to find the square root.
Yes.
Okay.
Now, if I give you a no calculator assessment,
It'll be easier.
I'm not going to ask you to find squares of 18 and 24. It'll be like much easier numbers. Okay? We good? All right. Alec, you were called while you were out, so you're up next. We're on number 4. We want to find sine if the terminal side of an angle goes through negative 15, 36. Guide me through that, please. Very good. It's a good starting point. So you need to find y and r. Very good. Y is just 36 from the given. It's not necessary. Let's try to do this one without drawing anything.
Alright, so r equals
Mm-hmm.
r equals square root of negative 15 squared
Good.
plus 32 squared.
Good. Good. The sum of those two. Okay, the square root of that. Good. Yep. And then reduce. Very good. Okay, everyone, you see how easy it is? It's just about x, y, and r. If you need to find r, just use the Pythagorean theorem. That's it. Okay. So 12 over 13. Next, Natalie, could you guide me through number 5, please?
Cosecant is r over y.
Very good. Cosecant is r over y.
And then 15 squared plus 20 squared equals 6 squared.
Mm-hmm. Yep, finding r with Pythagorean theorem.
And then 15 times 15 is 225.
Mm-hmm. 15 squared is 225.
Plus, plus 400
Good.
is 625.
Nice.
So then it's 25 is r,
Very good.
and y is 22.
Y is 20, so it's 25 over 20, and that reduces to
5 over 4.
5 over 4. Very good. Yes, ma'am.
How did you know that cosecant was r over y?
By definition,
Is it just one of those things that you can memorize?
yeah, but it comes from the Sokotoa Choshikau definitions. So cosecant, you might remember as the reciprocal of sine, or as hypotenuse over opposite. R is, yes, R is the hypotenuse, and the opposite is y. Okay? So if you like the Sokotoa definitions, which is fantastic, then x is the adjacent, y is the opposite, and r is the hypotenuse. Okay. Any other questions on 5? All right, we're on a bagel. Number 6. Random helper, Liam. Tell me, please, the definition of secant. Very good. Liam, I don't even need to find r. Because x equals 0. And you cannot sit on 0.
0 can sit on you.
That's right. Okay. Okay. It doesn't matter. It doesn't matter what r is. I mean, just so you know, r is 6 here. But who cares? Anything over 0 is undefined. Okay. We good? So undefined. Next, Vicky, number 7. Super simple. Tell me the definition of tangent.
Y over x.
Yeah.
So we just do 8 over 3.
Yeah. Yep. Okay, I'm sorry it's not more difficult.
No, that's fine. Don't worry. Okay.
Thanks. Thanks, you guys are good. You're good to me.
Now we're getting to
That's right. All things are difficult before they become easy.
True.
Okay. Next random person is Darian. Number 8, please tell me the definition of cotangent. Cow.
It's adjacent over opposite, which is x over y.
Yep. So what's your x?
Negative 9 over 3.
Yep.
So
And that reduces to?
negative
Good. Okay, negative 3. Good. Okay, these ones I think are pretty easy as well. Yes?
I'm waiting for the bus.
Oh, okay. Bye, bus. If you know Santa Claus, you can do these. They're just asking you, in this quadrant, is this ratio positive or negative? Remember what I told you about R. R is always positive. Okay? So quad 2 is here. I'll do one for you. The x's are positive, except they're not. In quad 2, the x's are negative. It's been a long day.
Feels like a
Therefore, you have a positive over a negative.
So negative.
Mm-hmm. There it is. So the significance of this, the reason that we're asking you to do this, is because it connects with a trig function. R over x is secant. So secant is going to be negative in the second quadrant. And when you start graphing trig functions, which is pretty wicked, you know, just wait until you see the graphs of these things. You understand, you know, when secant is negative and when it's positive.
If it's positive over negative, why is the overall negative?
That's a good question. Sometimes the simplest questions stump me because there's so much that I take for granted. I don't know. Does anyone know the answer to that?
What's the question?
When you divide a positive by a negative, the answer is negative.
Yeah. Just how it works. Is that how it works?
Okay. Yeah, I mean, the answer that just came to me, as opposed to just that's how it works, which was my first answer, is think about what division is.
No, yeah, now I get it now. I didn't. It's when a negative times a negative equals.
Yeah, do the inverse of division. It's multiplication. So you can get back to the numerator by doing the quotient times the divisor. So a negative times a negative is a positive. You might ask yourself, why is a negative times a negative a positive? That's a great question.
Two wrongs don't make it right.
Just how we
In math, they do, apparently. Okay. I will look that up on my own, and I'll see what I can find. Okay. All right, we're on number 10. Random helper is Shirley. In quad 3, are the x's positive or negative, Shirley? Negative. How about the y's? Negative, resulting in? A positive number. Very good. Therefore, in quadrant 3, cotangent is positive. Nice. Melanie, quad 4. X's positive, negative?
Positive.
Positive. Y's?
Negative.
Negative. Resulting in?
Negative.
Negative. Very good.
Thanks.
So cotangent is negative in quad 4. James, quad 2. X is positive or negative?
Negative.
Negative. Y's?
Positive.
Positive, leading to?
Negative.
Negative. I love how this class has a violinist.
There's 5 minutes.
Very
left.
talented.
How?
Very talented. How?
Yeah.
I just classed out my
No.
Be more specific, please.
For a number. Wait.
Wait for it.
Okay, never mind. I didn't see the full screen, so then when I looked at my paper, like,
It's the computer.
yeah, never mind.
Never minded. Brooke, quad 3, x is positive or negative?
Negative.
And r is
Positive.
always positive. Therefore, it will be
Negative.
negative. Okay, so cosine is negative in the third quadrant. Very nice. Backside. Julie, r, quad 4, positive or negative? Trick question. Doesn't matter what quadrant it's in. R is always positive. And, oh, okay. That I agree with, because the y coordinate is negative. Therefore, cosecant is negative in the fourth quadrant. Jake, second quad. Y positive or negative?
Y is positive.
Yep, x.
It's negative.
Therefore,
Negative.
very good. Therefore, tangent is negative in the second quadrant. Shirley, quad 3, r.
Positive,
Yep, x.
negative,
Good. Resulting in?
negative.
Good. Therefore, secant is negative in quad 3. Julie, quad 1, r is?
Positive.
Yep, y is?
Negative, so it's negative.
Quad 1, everything is positive.
Positive.
Okay? Therefore, cosecant is positive in quad 1, but everybody's quasitive. Quasitive, that's a good one. Good one. Everyone is positive in quadrant 1. Okay? All right. We'll do one more. A is an angle in standard position. We know that. We know what that means. And satisfies the given conditions. Find the indicated trig function value of A. Do not use a calculator. The terminal side of A is in quadrant 1. Okay. There you go. I made it in quadrant 1. Oh, and by the way, it lies on the line y equals 9x. Initial side is here for standard pos. Here's your angle. We want to find, oh, this is actually A. We want to find the sine of A. Oh, come on, this is so easy. Sine is y over r. Duh. Somebody give me a y coordinate that's on that line. 2? Well, actually, that's true.
No, it's, yeah.
Okay, but let me revise my question. I want to use like the easiest numbers possible. How about we make x equal to 1? Therefore, y will be 9. It's still about right triangles, friends. We got the y. Now I have to find r. Easy! Challenge me, why don't you? X is 1. Y is 9. Okay, so it's the square root of 1 plus 81, which is the square root of 82. So it's 9 over root 82, and that becomes 9 root 82 over 82. Sour cream. Dunions.